Alright, so in this example, we have this equation for the ellipse, which is 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. And what we want to do is we want to be able to find the coordinate for the center, both vertices, and the foci, so both of them. So what we need to do first is we need to put this into the standard form equation. So let me just go up here a little bit and show you what that looks like. Alright, so you might want to pause the video at this point and take down some notes. So standard form of an equation of an ellipse, there are two versions, and that's because an ellipse can either be long horizontally or vertically. Alright, so you can see this looks kind of similar, at least the numerator looks kind of similar to what the equation of the circle is, and you'll see that for all of our conics the equations are kind of similar. But now we have a squared and b squared, and you'll notice that in the second version the b and the a are switched. And so the way that it works is for ellipses specifically, because this is not going to be the same for other conics, but for ellipses, a is always the denominator that has the greater value. So if you had, for example, two denominators and one was 4 and one was 9, well, 9, because it's the bigger value, would actually be the a variable, and 4, well, you'd have to take their square roots, but that's how we would associate the a and b. So a is always the larger one, all right? And also notice here that when an ellipse that is long horizontally, or basically along the x-axis, notice that a is under the x value, all right? And then for an ellipse that is long vertically along the y, notice that the a value is underneath the y, all right? And so that's how we know where to place our a and b. Now, hk is still going to be the center. It's going to be a coordinate, all right? But we have these other values, a, b, and c. So you already saw a and b in the equations. A is technically the distance from the center to each vertex. All right, so it would be basically the center to the vertex, the center to the vertex. Now, mine obviously isn't the same on both sides, but then B would be the distance from the center to the co-vertex. So that's on the minor axis. So that would be like the center to here, or the center to here. Right? In this example, the vertices would be here because y is actually the major axis because it's the longer axis. So a would be the distance from the center to here, the center to here, and b would be the center to these 2 points. So it really depends on what orientation your ellipse takes. And then c would be the distance from the center to the focus. So I haven't drawn them out here, but the focus would be inside somewhere, and the focus is always along the major axis. If you want to find the exact spot for your focus, there's a formula for it. It almost looks like the Pythagorean theorem, but it's not the same. This is a squared minus b squared equals to c squared. And if you solve for c, you can figure out where each focus is inside of your ellipse. Alright, so we're going to use all of this information to solve this first example. So we only have this one and then one other. Alright, so the first thing that I'm going to do is I'm just going to rewrite this so that I have a little bit more space. But as I'm rewriting it, what I'm going to do is I'm going to work, I'm planning ahead a little bit. I'm going to go ahead and group my x's together and then my y's. So I have a negative 8x, I have a positive y squared, a positive 4y, and this negative 8, I'm going to move it over to the right side. And the reason that I'm doing this is because I'm going to have to complete the square. This is not in standard form, and so anytime that you want to put in standard form, you're probably going to be completing the square. Okay. So the first thing I'm going to do is I'm going to go ahead and I'm going to group the x's and then group the y's. Okay. So we're going to complete the square one time for the x's and another time for the y's. When you complete the square, your x squared term or the y squared has to have a coefficient of 1. So you can see that that's already the case for the y's, but not for the x here. So I'm going to factor out a 4, and then I'm going to have x squared minus 2x I'm going to leave a space because I'm going to complete the square. And then I can just group my y's as well, leave a space. Okay, so just be really careful that you always do that. You don't want to miss that, or else you're going to complete the square incorrectly. Alright, so when we complete the square, don't forget that you take b, you divide by 2, and then you square it. So b is negative 2. Negative 2 divided by 2 is negative 1. Squared is a positive 1. Okay, now remember that what you add to the left side, you have to add to the right. But here, this is interesting because we actually don't have a value of 1. Notice that we factored out a 4, so if we redistributed, this value wouldn't be 1, this value would actually be 4. So I'm going to add 4 to the other side. Or if you want, I'll write it like this because it's technically that 4 times 1. Okay. Now for the next one, for the y's, I'm going to take my b, which is 4. 4 divided by 2 is 2. 2 squared is 4. Okay. So let's go ahead and continue to factor. Alright, so if I factored this perfect square trinomial, it would become x minus 1 squared. And for the y's, I would have y plus 2. I'm just factoring. And then 8 plus 4 is 16. Alright, so we're almost there, but notice that in our equation for ellipses, they always have to equal 1. So what I'm going to do, since this doesn't equal 1, is I'm going to divide everything, because if I do it to one side, I have to do it to everything. I'm going to divide by 16 so that that side actually equals 1. So here, all I need to worry about are the coefficients. So 4 over 16 becomes 1 over 4. So I don't need to write the 1. This coefficient is technically a 1 over 16, nothing to simplify there, so I just have y plus 2 squared over 16 equals 1. So this is our standard form equation for the ellipse, but we're not asked to find the standard form equation, we're asked to find the center, the vertices, and the foci. So that's why we need this information. Alright, now I want you to notice one thing. This value right here is the larger value. Alright, that means this is our a, or this is technically our a squared, so a would be 4. Alright, if I rewrote this in factored form, that would be 2 squared. 16 would be 4 squared. So a is 4 and b is 2. Alright, so let's go ahead and find the center. Our center is hk. Remember, h is always with your x, k is always with your y. We have to take the opposite. So this is going to be a positive 1 and a negative 2. Okay. Now my vertices. All right. Because this ellipse is long along the y-axis, I'm going to add a value to my y-coordinate. Okay. So my vertices are both going to start with 1 because the x value is not changing, the y value is changing. So remember that because this is A and this is B, A is the distance from the center to each vertex. Okay? So it's basically half of the major axes are here, center to the vertex. If I want to find this coordinate, I just need to add however many units exist in between here. Alright, so I know that A is 4, so I'm going to add 4 to my y value. Negative 2 plus 4 is positive 2. So I just went up, but I need to find my other vertex, which from the center would be down 4 units. So negative 2 minus 4 is negative 6. So those are the two vertices. And then I need to find the foci. Now, to the foci, I basically would do the same thing as I would just add the c value to the y coordinate from my center. But I don't know what c is. So I need to use the equation c squared equals a squared minus b squared. So I'm going to do that off to the side here. Alright, so a squared A is 4, so 4 squared is 16. B squared, which is 2 squared, is 4. So c squared equals 12. Well, I want to square root both sides. So c is going to be plus or minus, and square root of 12, I can rewrite that as square root of 4 times 3, so that reduces to 2 radical 3. Always, always, always simplify the radicals, always. Okay, so what I'm going to do now for my foci, I'm going to do negative 2 plus 2 radical 3. Now that number is going to be, if I put in the calculator, it's going to give me a decimal, and I don't want to round. So the most exact way to write that coordinate, even though it's going to look weird, is to actually just write negative 2 plus 2 radical 3. Okay, that whole thing is a number. It's going to be a crazy number, but that's the y value. And then for my second foci, because there's one on each side, or in this case vertically, one above the center and one below the center, I'm going to do negative 2 minus 2 radical 3. Alright, so there I have my center, my vertices, and the foci.